Welcome to Hope Academy. My name is Mr. O, and today I'm going to be talking about the unit circle. Okay. This concept is usually covered in is an essential backbone of the pre-calculus as trigonometry based course. And it sometimes causes a lot of trouble for students. Why? Because the unit circle is quite something that is not easy to get over with right off in the beginning. And it could look very intimidating. And so today I'm going to explain to you different strategies to understand the unit circle, but also what I personally believe is the best strategy in order to beat the unit circle and so on. And so I'm going to go ahead and do so. So the unit circle will look something like this, and I'm going to try my best to draw a circle. Okay, I'm not the most perfect artist by any means, but there's my circle. Okay, and it looks a little lopsided. But that being stated, the unit circle usually looks like this. It looks like sort of like a coordinate thing. And the part is this. So a lot of times how the unit circle works is that we assume that this circle has a radius of 1. What do I mean by that? That means that starting from the center point right here to whatever the end point is, let's say right here, and I'm going to actually construct part of the unit circles right now. Right here, all of these are going to be of length 1, okay? And so when we discuss this in the idea that the length is 1, what we can actually do is reimagine this as if it's a triangle. And I'm going to use different colors for this. So for example, I can imagine as if, and I'm going to create the dotted line, that there is a right triangle right here, and I could extract it. So I'm going to take out this right triangle real quick and recreate that right triangle. As I mentioned before, because the unit circle is radius 1, that means the hypotenuse of this triangle will be of length 1. And how this triangle usually works when I'm labeling things is the fact that it goes by different angles or measurements. So for example, this from this base value, everything is going to be relative to this original angle right here, which I'm going to state is 0 degrees. Okay, that's the part, because we're starting here, and so whatever starts here, we will always assume or believe that everything goes in a counter circle sort of counterclockwise system. And so we're starting at 0 degrees down there. Every time we go a certain pacing, this will be 30 degrees, this will be 45 degrees, this will be 60 degrees, and this will be 90 degrees. And I'm only going to focus on what we call the quadrant 1, or the first portion of the circle. And there is a pattern that does exist, so I will talk about that in a bit. But this is the first way we could actually help ourselves memorize this. So the first way requires you to know what we call the special triangles rule. Okay? And please do review the special triangles rules if needed. And I will create a video based on this concept. But when we talk about special triangles, and we talk about, let's start with like the 30-degree concept. Right here is going to be 30 degrees. Okay, that also means that if this is 90 and 30, this will be 60 degrees. And we do use the special triangle rule, which states that in a 30, 60, 90 triangle, we know that the hypotenuse is going to be represented by the value of 2x. That this is going to equal to 2x. Okay? And whatever is right across from the 30 degrees is going to be represented by x. And whatever is represented across the 60 degrees will be just x root 3. Okay? And so the reason why it's so important to remember this strategy is just because to be aware that unit circle and all the math concepts you have learned before all are intertwined with each other. And so that means that for this equation, because 2x equals to 1, we know as a fact then that x is going to equal to half. If I solve for x is going to equal to half. And since x is going to equal to half, this will be half times 3 over 2, or square root 3 over 2. And that's where the coordinates, if you're learning about the unit circle and such, come in for the 30 degrees, where it's going to be this x coordinate right here, this x right here is going to be square root 3 over 2, and I'm going to write it up here, square root 3 over 2, comma, up here it's going to be half. And that's where the coordinates come in. Okay, and right now I'm all talking in the terms of degrees, but I will soon enough elaborate on the other format that you might have heard of, which is called the radians. But for now, I'm just going to discuss this strategy. So the same type of strategy will apply if I do 45 degrees. If I go to the 45-degree triangle, and I'm going to use, let's say, the color blue, and this 45-degree triangle right here, and I'm going to try to recreate it per se. It's going to be like the dotted line here, and I can recreate this triangle right here, and I'm going to bring it down here so you can see it. It's going to look something like this, okay? And for this triangle, it's 45 degrees, as I mentioned before. So on that angle right here, it's going to be 45 degrees. That means that if it's a 90 degrees here, this means also this has to be 45 degrees. And the reason why is because all triangles add up to 180 degrees. And so for this type of question, I need to remember the 45, 45, 90 special triangle rule, which states that this hypotenuse, which is actually going to be 1 again, because last time I told you, the circle hypotenuse will always be, because of the circle, the hypotenuse will always be 1. This will be x root 2 because of the theory. The theory states that x root 2 will be where the hypotenuse is. And that means that these will also be where x is. And if you solve it out for yourself and take the time to do so, you're going to actually find out that when you solve for x on this, it's going to actually simplify and become, and I'm going to use the right color, sorry about that, it's going to be root 2 over 2, root 2 over 2, the same value. And so that's why for the coordinates up here for the 45 degree triangle, it's going to be square root 2 over 2, comma square root 2 over 2. Okay? And for 60 degrees, at least my personal trick is that I know that 30 and 60 have a very similar rule where the angles sort of swap. So just as much as these angles swap, the sides will also swap. So square root 3 over 2 will be on the other side where half is. So it'll be half comma square root 3 over 2. Also be aware that I also need to mention that for 0 degrees, for example, because this is radius of 1, this will be 1 comma 0, and this will be 0 comma 1, like this. And that sort of concludes my breakdown of the unit circle, the one strategy in which to really understand how the unit circle works and to see how is it broken down and so on. But that being stated, I do also want to state that the radian values and whether or not the conversion between them will look sort of like this. And I'm going to go ahead and get a blue marker out to show that. So a lot of times, 30 degrees, it's going to convert based on the idea where we multiply pi over 180. This is just something you need to memorize. And what happens is that when I simplify and solve it out, it's going to be pi over 6. So every time I do 30 degrees, it's going to be pi over 6. So if I add 30 degrees more, which is going to be 60 degrees, I add pi over 6 amount. So be aware that for 30 degrees, like this value, it's also going to be represented by the radian value of pi over 6. And this will be 2 pi over 6. If I add another pi over 6, 2 pi over 6, which is going to be pi over 3, simplified. Add another pi over 6, it'll be 3 pi over 6, which if I simplify will be pi over 2. And so on. When I do 45 degrees, it's always going to be increments of pi over 4. And something I do advise memorizing. Once you add pi over 4, it'll be 2 pi over 4. Or it's going to be 45 plus 45 is 90 degrees, which is pi over 2. Okay? And the routine does work like this. This is the strategy in which to memorize the unit circle. So the second strategy is I want to mention is the memorization. I do recommend memorizing unit circles and actually just being so fluent at it and practicing it that you could jump around between angle and values and such like that. So that if you look at like 150 degrees, for example, and I just chose a random angle. So let's go with like 150 right here. 150 is around here. I'm going to know right off, it's going to be actually negative square root 3 over 2 comma half. Okay, whoops, let me use the right color. Negative square root 3 over 2 comma half, and I know it's going to be 5 pi over 6 also. The reason why is that, for example, I know that because this is 30 degrees away, it's similar amount of distance as this 30 degrees. But using the x and y coordinates, I know that the x is going to be negative, y is going to be positive. And so right off, I know it's negative square root 3 over 2, half. And there is this pattern that does exist throughout this whole unit circle. That's so important for you to notice. Because it will help you memorize this unit circle, which is the second strategy that I highly recommend. The reason why is that when you get into the higher level mathematics, such as AP Calculus, AB, BC, and such, it is actually expected for you to be very fluent on solving this out real quick. And it will save you a lot of time. And so this is my high recommendation that you do memorize the unit circle in the very end, but be aware of the properties as to how could you create the unit circle in case you do not remember it. But that being stated, the last strategy that I heard about is the unit circle hand system. And that one you could always look it up and see how people explain it. It's based around the idea that the fingers are going to represent different angle measurements like 30, 45, 60 degrees and then 90 and so on. And this strategy does work for some people. I've seen some people really struggle with it and not get that hand strategy at all. But it is something I do want to mention in case you do want to look into it and see if it'll help. But that being stated, that is my explanation around the unit circle. Thank you so much for watching this video. Please do subscribe to our YouTube channel, like our Facebook page, follow us on Twitter so that we could continue to make content like this. I hope you have a wonderful day.